in the volume of similar figures. Instead of area factor, we have volume factor. But the volume factor, we normally call it scale volume. The relationship between the scale factor, which is also existing in volume of similar shapes, the relationship between the scale factor now and volume factor, or ratio of volume, is that the scale factor is equal to the root of the volume factor, and the volume factor is the scale factor exponent 3. That is the scale factor raised to power 3. That will give you the volume factor, or the ratio of the volume. Scale factor is equal to the third root of volume factor. This volume factor is also called ratio of volume. Then the volume factor now is equal to the cube of the scale factor. Scale factor raised to power 3, or the cube of scale factor. When we get into solving problems properly now, we are going to be mentioning volume factor, or ratio of volume, and scale factor. If you pay attention, you are going to understand how to marry both of them in solving questions. It says two similar vibrated blocks have corresponding edges measuring 10 cm and 20 cm. We are asked to calculate the ratio of their masses. Ratio of their masses. In this concept, whenever you hear about mass, understand it to be the third of volume. Mass is equivalent to volume in this concept. If the word volume is not used, mass could be used. Always see them as being equivalent to themselves. Now that they said we should calculate the ratio of their masses, it is something as saying that we should calculate the ratio of their volumes, or the volume factor. First of all, the scale factor. The scale factor of the two similar vibrated blocks are 10 divided by 20, which is the same thing as 1/2. Now the volume factor. Volume factor, or ratio of volumes, is equal to the cube of the scale factor, which is 1 cube divided by 2 cube. 1 times 1 times 1 will give you 1. If you like, multiply 1 by itself till the end of the world. The answer remains 1. That makes 1 a serious number. 2 cube means 2 times 2, 4. 4 times 2, 8. So we have 1/8. So the ratio now is 1:8. That is the ratio of volume, or the volume ratio, or the volume factor. Whichever way you like, you can call it. They all mean the same thing. The second question says that a student blew a balloon. You know what a balloon is? To a diameter of 4 cm And he continued until the diameter increased to 8 cm. Calculate by what ratio the volume of the balloon increased. What you're asking here is the volume factor. Now the scale factor here is going to be this factor or the fraction of the first volume or the first diameters, which is the same thing as 4 all over 8. That is the scale factor. Now the volume factor. Volume factor is equal to the cube of the scale factor. If you should bring down this fraction to its lowest term, remember it's going to give you 1 over 2. 4 divided itself will give you 1. All over 4 divides 8 will give you 2. So the volume factor now will be 1 cube all over 2 cube, which is 1 all over 8. Now the ratio is just writing this volume factor in ratio form. That will give you the ratio or the volume ratio, ratio of volume. One is to 8, and that answers that question. Question number 3 said the diameter of two similar metal bolts are 15 millimeter and 5 millimeter and 15 millimeter. A said we should find the ratio of their masses. I told you, masses means volumes in this concept. So as they say we should find the ratio of their masses, they are asking for the volume factor or the ratio of the volumes. Number 2 said assuming the smaller bolt weighs 12 grams, calculate the weight of the bigger bolt. So the scale factor is already lying inside the equation. Scale factor is going to be 5 all over 15, which is giving you 1 all over 3. 5 divided itself is 1. 5 divided 15 is 3. Now, question number A is asking for the volume factor or ratio of volume. So, volume factor now. Volume factor is the cube of scale factor. It's going to be 1 all over 3. 1 cube all over 3 cube. And it's going to be 1. 3 cube means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So we have 1 all over 27. If you write this fraction in ratio form, it has answered question number A. As volume, ratio of volume now. Ratio of their volumes is now equal to 1 is to 27. Now question number B. Question number B said assuming the smaller boat weighs 12 grams. Now look at this. Weight we are talking of now is also the same thing as mass. And I told you it is equivalent to volume in this concept, in this topic. If the smaller one weighs 12 grams, they're not asking for the weight of the bigger one. So let's start by let the weight of the bigger boat be be represented by X. X now is the weight of the bigger boat. So X all over the representative of the bigger boat in the volume factor, which is 27, will be equal to the mass or the weight of the smaller boat, which is 12, divided by the representative of the smaller boat in the volume factor, which is 1. In this relationship now, if you cross multiply X times 1, we give you X. Now be equal to 12 times 27. And if you multiply 12 and 27, 12 times 27 is giving me, that means our X now will be 324 millimeters. Sorry, grams, because they said the smaller one weighs 12 grams. And that answers the question. Kids have capacities of 13.5 liters. Question number 8 said we should find the ratio of their heights. B, if the bucket is centimeters, the height of the smaller bucket. Now, there are two similar have capacity. Capacity means volume of 13.5 and 4 liters. These are automatically the volume factor. And from there you can have the ratio of the volumes because they are representatives of the volumes. Capacity means volume. That means that our volume factor is equal to 10.5 all over 4. Now our scale factor is going to be the cube root of volume factor. The cube root of 13.5 all over 4. So let's find the cube root of 13.5. Giving me 0.38. I want to round it up to 2.4. I round it up to 1 decimal place. Then all over the cube root of 1.58. I will also round it up to 1.6. To have this as a single fraction, multiply both of them by 10. 2.4 multiplied by 10 will give you 24. This one will give you 16. 24 all over 16 is the same thing as 2.4 all over 1.6. So the ratio now, which question number A is asking for, let me write number A, is 24 is to 16. If you like, you can break this thing down. 4 can divide this to give you 4. 4 can divide this to give you 6. 2 can still go. 2 can divide it to give you 2. 2 can divide it to give you 3. So the ratio now is 3 is to 2. It can still be 2 is to 3, depending on if it was 4 that was the numerator or the denominator. Question number B says we should calculate the height of the smaller bucket if the height of the larger bucket is 36. Let the height of the higher or the larger bucket be represented with y. Now this y now, the height of the smaller bucket, sorry, we are given the height of the larger. We are asked to calculate the height of the smaller. So if the height of the smaller bucket is y, in this scale factor, remember we are talking of height now, so we should go to scale factor. And maybe we are talking of volume or mass, we could have gone to volume factor. So y is the height of the small bucket. 2 is being represented in this scale factor, or is representing the small bucket in the scale factor. So you have to divide the height of the small bucket by what is representing it in the scale factor. And it's going to be equal to the height of the bigger bucket, which is 36, divided by what is representing the bigger bucket in the scale factor, which is 3. In this relationship now, we can find y, which is the height of the smaller bucket. Cross multiply here, y times 3 will give you 3y. And it's going to be equal to 2 times 36. 2 times 6 is 12. Raise 1. 2 times 3 is 6 plus 1. That's 7. If you divide both sides by 3, you'll be left with only y in the left hand side. In the right hand side, you have 72 divided by 3. 72 divided by 3 is 24. So we have y is equal to 24 watts, centimeters. That is the height of the smaller bucket when the bigger bucket is 36 centimeters and the scale factor is 3:2. A cup of beans costs 8 naira. How much will a similar cup 3 times the height and diameter full of beans cost? The scale factor here lies inside the sentences. I'm going to help you extract it. How much will a similar cup 3 times? That means if the height or diameter, first of all, let's start by saying let the diameter or the height, let the height of the small cup be represented by x. If the height of the small cup is represented by x, that means the height of the bigger cup or the big cup will be (3x), because they said the big cup is 3 times the height and diameter of the small one. Now the scale factor is now from here now. Scale factor is now equal to x all over 3x. And x all over 3x is something as 1 all over 3. Okay? They're asking for the cost. The cost of the bigger cup full of beans. That bigger cup full of beans, the cost now is equivalent to the volume. That means let's calculate volume factor. Volume factor, is the cube of scale factor. So we have 1 cube all over 3 cube, which will give us 1 all over 27. 1 times 1 times 1 is 1. 3 times 3 is 9. 9 times 3 is 27. Now it is from here now that we'll be able to calculate the price of, now they said the price of the smaller cup is this. So let the, now let's start here. Let the costs of big cup, then the costs be X. If the cost of the big cup is X, then X divided by the representative of the big cup in the volume factor, which is 27, will now be equal to the cost of the small one, which is 8 given in the equation, divided by the representative of the cost of the small cup in the volume factor, which is 1. With this relationship, if you cross multiply, discover that X times 1 will give you X. And it's going to be equal to 28 times 8. Sorry, 27 times 8. Let's find 27 times 8. 27 multiplied to 8. X is 2,116 naira. And that answers that question. A pencil manufacturing company made a giant model of pencil 3 meters long as the company's symbol. A normal pencil is 18 cm long and has a volume of 9 centimeter cube. Calculate in meter squared or in meter cube the volume of the symbol. The first thing we do here is to convert 18 cm to meters and also convert 9 cm cube to meter cube. 100 cm is equal to 1 meter. You know that one. Therefore, 18 centimeters is going to be 18 divided by 100, which will give us 0.18 meters. You can use a calculator to confirm this. So let's convert 9 cm cube to meter cube. The parameter is that 1 million cm cube is equal to 1 meter cube. Therefore, 9 cm cube is going to be 9 divided by 1 million. And 9 divided by 1 million is going to give us 0.12345 1, 2, 3, 4, 5, 6. You can use a calculator and confirm it. This is now in meter cube. Sorry, this is meter cube. Volume factor. Our scale factor now is going to be length of the normal pencil, which is 0.18 meters, divided by length of the symbol, which is 3 meters. This is our scale factor. Then our volume factor, or ratio of volume, is going to be the volume, that is the cube of the scale factor, which is 0.18 divided by 3 all cubed. So let's use our calculator. 0.18 times 0.18 times 0.18 is giving me 0.005 832. All over 3 times 3 is 9, 9 times 3 is 27. So we have all over 27. This is our volume factor. Now the question says that we should calculate in meters squared the volume of the symbol. Let's start by saying let's the symbol's volume be represented by x. Let it be x. Let's build the equation x, which is the volume of the symbol the equation is asking for. If you divide it by the volume of the normal pencil, which we calculated from 9 centimeter cube to become 0.000009 meter cube. So divided by 0.1, 2, 3, 4, 5, then 9. 1, 2, 3, 4, 5, then 9. Is going to be equal to, come to the volume factor now. X is for the symbol. 29 is for the, 27 is for the symbol. So put 27 up. Then this figure, 0.005832, which is for the normal pencil, will now come down because this one is also the volume of the normal pencil. So we have divided by 0.005832. So with this equation now, we can cross multiply. So permit me to clean up the space so that we will complete finding out x, which the equation is asking for. So you have, if you cross multiply now, you discover that x will multiply this figure. And you are going to have x times 0.005832. X times this will now be equal to 27 times this. You have 0.12345 Let's multiply out this and see what it will give us. 27 times 0.000009 is giving me 0.000243. That is x times this. Then if you okay, let's see, bring down x times so that you follow suit. Now you are going to divide both sides by this figure, 0.005832. So that we'll be left with only x in the left hand side. And in the right hand side, we are going to have 0.000243 divided by this figure, 0.005832. Okay? Whatever we get now is the final answer to x. 0.000243. The numerator divided by 0.005832. It's giving me 0.0417. 0.0417. I've rounded it up to 4 decimal places. Since it's asking of volume, so this is going to be in meter cube, and that is the answer to that question. With this question, I want to drop my curtain, close my door, in volume of similar figures, a subsection of area of volumes of similar shapes. And And the question said, in a school's scale drawing means drawing a very large place in a small paper. That is what scale drawing is. A part 120 cm wide in the real land or in the real school is represented to be 15 millimeter wide in the paper. The question is not saying that we should find the scale of the drawing. It's a very simple question. But at times students used to run away from this kind of question. So the first thing we do here is to change millimeter into centimeter. The parameter is that 10 millimeter is equal to 1 centimeter. Therefore 15 millimeter is going to be 15 divided by 10 centimeters. That is 1.5 centimeters. Now the scale, 1.5 centimeter on paper, representing 120 centimeter on real school compound. That means the scale now, the scale factor, is equal to 1.5 divided by 120, which is something as 1.5 is to 120. We can bring down this. Let's divide 120 by 1.5. Giving me 8. So this ratio is something as 1:8. 1 cm inside paper representing 80 inside the real compound. And this brings us to the end. So this is the scale drawing, the scale for the drawing. And it brings us to the end of that topic, area and volume of similar shapes.